In this video, we're going to start looking at linear functions. But before we go on, I want you to look at the problems on that first set of activities called Introduction to Linear Functions. You may not be able to get through all of them, but I at least want you to look through a few of them to get an idea of some of the things that we're going to be talking about in this video. It'll make things make a lot more sense. So I'll give you some time here to pause and work on those. Okay, so as I mentioned, we are going to be looking at linear functions. The first thing we're going to do is look at the activities that you just did and summarize some observations from those. We're then going to define what a linear function is. We're going to generalize those observations from the activities to linear functions in general. And then we're going to show how to find the equation for a linear function given certain information. So first of all, let's think about that first problem that you did on the in-class activities. So what you were given was a function f where f of 4 was equal to 7, and that the average rate of change between every single pair of points is 2/3. And then, first of all, one of the things you notice that given the information, it appears that by doing a little bit of algebra, doing a few computations, you could find any point on the graph. So knowing that f of 4 was equal to 7 and that the rate of change was always 2/3 could enable you to find any point on the graph. And the second thing is when you plotted some of those points that you found, the graph appears to be a straight line. For the second problem, we gave you the formula for a particular function. It was f of x equals 8x plus 3. A few things that you found in your computations was that the average rate of change between every pair of points is always the same, and it happens to be 8, which is the coefficient of x in the formula. Not a coincidence, by the way. And then the second thing is when you graph that on Desmos, it appears to be a line. And in the last problem, you looked at the information of the problem in number 1, where f of 4 was equal to 7 and the average rate of change was always 2/3. And then it turns out we could find a formula for the function just given that information. And so you figured out what that formula was. I won't go through the details on that one, but you ended up with 2/3 x plus 13/3. That was your output. And then as in number 2, the average rate of change was the coefficient of x in the formula. In problem number 2, the coefficient of x was 8 and your average rate of change was 8. And in problem number 1 and problem number 3, your average rate of change was 2/3 and the coefficient of x was also 2/3. So given that, it seems that we can generalize those to all functions that kind of behave this way. So if we want a function whose graph is a line, and this is what we're going to call a linear function, we seem to know a lot of things about it. First of all, we know what the formula is going to look like. It's going to look like f of x equals mx plus b, where m is a constant and b is also a constant. The m appears to be the average rate of change between not just 2 points that are given in the problem, but any 2 points on the graph. And given the information about f, knowing the rate of change and knowing the point on the graph, it turns out we should be able to find the formula for that function, and it should be of the form f of x equals mx plus b. So our definition of a linear function is a function f that has the form f of x equals mx plus b, where m and b are constants. It turns out that constant m is the average rate of change between any 2 points on the graph, and we also call m the slope of the function f. So it is the average rate of change between any 2 points on the graph, and we call it the slope because it tells us how steep the graph is, and it also tells us whether the graph is running uphill or downhill. So let's look at an example. So suppose we have a function f where f of 8 is equal to 3, and the average rate of change between any 2 points, in other words, the slope, is always 4. So let's see if we can find a formula for f. All right, so we really want a formula for f of x. So x is our input, f of x is our output. We want a formula for f of x that just depends on x. So I know I don't really have to say this, but yes, x is the x-coordinate. Also important is that f of x is the y-coordinate. So if we want to think of this as an ordered pair on the graph, the point is going to have x coordinate x, y coordinate f of x, so we're going to get x comma f of x. That's going to be a point on the graph. So why is that important? Well, we'll see in a sec. Second of all, we know that 8 comma 3 is also a point on the graph, right? Because 8 is an input, f of 8 is equal to 3. So if 8 is the input, 3 is the output. So 8 is the x coordinate, 3 is the y coordinate. So if we want to find the average rate of change of the graph, actually we have two possible ways of answering that question. First of all, we are given in the problem that the average rate of change is 4. That is just information that was given to us. But we also know what the definition of the average rate of change is, and we have 2 points on the graph. We have x, f of x is one of the points on the graph, as noted a couple lines up, and also 8 comma 3 is a point on the graph. So we can find the average rate of change using the average rate of change formula. We subtract the y coordinates, subtract the outputs, subtract the inputs, and divide them. Now, both of these represent the average rate of change. That means they have to be equal to one another. In other words, f of x minus 3 over x minus 8, one way of thinking about the average rate of change, is equal to 4, which is another way of thinking of the same average rate of change. And now we can use this equation to find a formula for f of x. So we have f of x minus 3 over x minus 8 equals 4. Probably one of the smart things that we can do is multiply both sides by x minus 8 to clear that denominator on the left side. When we multiply the left side by x minus 8, the x minus 8 will cancel to give us f of x minus 3. When we multiply the right-hand side by x minus 8, we'll get 4 times x minus 8. And now it's just a matter of solving for f of x. So the easiest thing to do in the beginning probably is to add 3 to both sides. We get f of x equals 4 times the quantity x minus 8 plus 3. If we want to simplify, we don't have to simplify it if we don't want to, but what the heck, let's simplify it so it looks more like a linear function. We can multiply out that 4 to get 4x minus 32, and then we still have that plus 3. And then we can clean that up a little bit to get f of x equals 4x minus 29. So now that you've seen how we can handle these linear functions, now you can finish working on those activities in that introduction to linear functions that I tried to make you look at the beginning of the video. And then you might notice there's a second set of in-class activities along with this video called computing linear functions. You're ready to work on those as well.